So we again come with a question of LCR circuit. This is also come in CBSE 2016 paper. So the question is like this way. So we have a capacitor of 2 microfarad, resistor of 100 ohm, and inductor of 8 Henry, which are connected in series AC source. Okay, so this is the point given. So now we have to find out, means in this question there are two sub questions. The first part is what should be the frequency. First part is what should be the frequency of the source such that the current drawn in the circuit is maximum, and what is this frequency called. The point is here, the point part section is that the source such that the current drawn in the circuit is maximum. Okay, the maximum current which drawn from the circuit is what? A condition for, that's the condition for what? Resonance. That is the condition for resonance. Okay, so let's start for the question number, very first question number 1. So when the current drawn by the series LCR circuit is maximum at resonant frequency, we have to write it. Okay, current is maximum in series LCR in condition of what? Resonance. So while calculating the formula for the resonance frequency, we have the resonance frequency mu naught is equals to 1 by 2 pi root upon LC. So just write down the values equals to 1 by 2 pi root upon. The value of L, that is inductor, is 8 Henry. So we can write 8 into. Now the value for C is 2 microfarad. We can write 2 into 10 to the power minus 6. That is a farad. Okay. So now just moving to the next part. Mu naught is equals to 1 by 2 pi root upon 8 to 16 into 10 to the power minus 6. Just break the root, equals to 1 by 2 pi. 16 root is 4 and 10 to the power 6 become 10 to the power minus 3. Okay, now solve it again. Mu naught equals to 1 by 8 pi into 10 to the power minus 3. So this can be written as 10 to the power 3 by 8 pi. So 10 के power में 3 means 1000 by 8 pi. So 8 and 1000 can be cut by a table of 125 pi. So what we can write, the resistance, sorry, the frequency, the resonance frequency for the maximum current mu is 125 pi. So this is the first value for the mu naught. Okay, so we get the answer of this. Now come to the second section. The second section is if the peak value of EMF of the source is 20 volt, find the maximum current. Means we have to find out the current when the source EMF is 200 volt. So the maximum current formula is very simple. The maximum current formula is what? Second number. The maximum current we have to find, that is I max, which is equals to V naught by R. Because the just look at which for maximum value of current, for maximum value of current, XL must be equals to XC. When XL is must be equal with XC, when XL is equals to XC, then whatever the value of Z, that impedance must be equals to the R, must be equal to the R. So the formula which may be I max is equals to V naught by R. Sorry, not V naught by R. This is V naught by Z. So this Z now becomes R. That's why the formula I max is equals to V naught by R. Okay. Now just put the value of V naught. The value of V naught is given. Just look here there. What is the value of V naught is 200 volt. So we can write here 200 by the value of R is the maximum resistance of the circuit is 100 ohm. So we can write 200 by 100. So we get 2 ampere. So the value for I max is equals to 2 ampere. So this is one of the most important questions for LCR circuit. Okay, so for in LCR circuit we completed up to 3 questions. Okay, and all 3 questions are belong to the CBSE boards paper. So we'll meet in another questions. तब तक के लिए आप just subscribe my channel for more questions and for more updates. Thank you.